Good morning and welcome to this week's episode of Context. I'm Shannon Williams. I'm super excited to have you all here with us today. And today my co-host is going to be Shen Liang. So Darren is out today, so Shen stepped in to join us. And Shen, thanks a lot for joining us. We should have a really good conversation today. Mark Williamson is here from Undo, and we're going to talk a lot about how to do debugging with coding agents. And I think it's going to be a really interesting conversation. For those of you who have been kind of following the context, we have posted all of the talks from the Dev Summit in London. There's 30 some odd talks. They're all up on YouTube. They're excellent across the board. There's a lot of really good conversations about security, really good conversations about the future of the standard. There are some excellent talks on how to manage the large number of tools and sort of kind of take, kind of more unique approach to tool calling and tool management. So I highly recommend taking a look. You can find them all on our YouTube channel. The New York event will be our next event. It's going to be April 2nd and 3rd in New York City, and it's going to be even bigger and even better. We have not yet opened up the call for papers, but we should be opening that up soon. If you're interested in getting involved, if you're interested in joining, please feel free to reach out to me. You can find me on LinkedIn and let us know, because we're always looking for people who want to be involved and help in the planning stages or as sponsors or as speakers. So lots more news to come on that over the next couple of weeks. The context has been going strong. We've had many great talks the last few weeks. They are always up on our YouTube channel. If you are, if you're looking for really any piece of content about MCP and how it's being adopted, what people are using to build them, how people are using them, there's probably a great episode in there. So definitely follow us on YouTube, like the videos, and share them with your teams. If you would like to speak, we have a call for papers sort of approach. You can submit a talk anytime. We're always welcoming them. Right now, the wait is pretty long. I will say we've got talks booked for the next few weeks, including a couple talks I'm excited about. The next week's talk from Haley at IBM is one that we've been hoping to get on for a while. She wrote a really detailed paper on MCP security, and she's going to be kind of diving into that in a lot of detail. So I'm looking forward to that talk. But there's just loads of good stuff coming. And I think we've got a great talk today. So we're going to try and keep it fast. We always move through these talks in sort of about 20 minutes. And if you have questions, feel free to submit them on Twitch, YouTube, LinkedIn, or X, wherever you're watching. And at the end, we'll post all of the videos to YouTube. So feel free, if you see something you're interested in or you have to run, to go find it again and share it with your team. And with that, we can get started. I'm excited for Mark's talk today. We're supposed to have two talks today. Lois was going to be here from Tomo, but she had a P0 and kind of an emergency came up at work this morning, and she had to cancel. So we have a 20-minute day, and Mark is going to take us off and tell us about time travel. Mark, it sounds like it's going to be a very interesting talk. So thanks, Mark. Yeah, the floor is yours, my friend.
Cool. Hopefully this will be a fun ride. So I want to talk about what we call agentic debugging, which we'll come to, but I'm going to start out with a bit of an introduction to who I am, who Undo, my employer, is, and what time travel debugging actually is. So who am I? I'm Mark Williamson. I'm the CTO at undo.io, which basically means these days I pretend to be a programmer. So my original background is in systems programming. I worked in virtualization, kernel programming, embedded programming for some years. And then I arrived at this funny little company called Undo, who were trying to build time travel debugging. When I say time travel debugging, I mean debugging which is capable of capturing everything a program does and then rewinding it, replaying it, and analyzing it in any detail you want. But we'll get into more detail on that. So, first of all, what happened? That's the question that I spend a lot of my productive development time asking. Not about cows, but I think the key thing about reasoning about what programmers actually do is it's not the typing. It's not the code that software engineers spend most of their time doing. I would guess it's probably about 15% of our time we actually spend inputting the code into the computer, generating new code. Some of it, the rest of the time, is spent on meetings and stuff like that. There's no two ways about that. You have to talk to the other humans sometimes. But a lot of the technical work is actually what I'd call debugging, which I mean trying to figure out what was really going on in your code. Usually this means somebody else wrote it, or the somebody else was you a year ago, or maybe it was you yesterday and the code is still not doing the thing you intended. The point is that actually most of our engineering effort, most of our brain power goes into figuring out what did the code really do. In other words, our job is mostly this. So the question then is, how do we deal with this world of utter madness that we live in, where we're creating artifacts that even we can't understand or explain? And generally, the answer boils down to two things. Number one, you put more logging in. So your excuse for slacking off is you're waiting for printf to do things, and you're angry because of that. The other option is you use what we call a debugger. And a debugger gives you the ability to attach to a program in some way and inspect its state from the outside, sometimes to manipulate the state. And it gives you the ability to step through the program a line at a time and see how state evolves. And generally, these debuggers exist for any language under the sun. Eventually, someone always implements them because they're useful. People are also resistant to using them. One of the reasons is the scenario here, where you really want to step to the point where a bug occurs, and then you step one time too far because you got into a bit of a haze, and then you realize you don't have the state you needed anymore. The nice thing about logging is it never accidentally goes away. If you have the logs for the program, then you have the information. You can scroll up and down in your logs to see how the story unfolded. The downside is this delay. You have to keep going back and adding more logs when you realize that you didn't have the thing you needed. In fact, I would generally say that if you knew exactly what logging you needed to put in your program in order to diagnose a bug, you would not have written the bug in the first place. So there's a fundamental trade-off here. Both of these are not ideal. What we do with time travel debugging is try and get you both. So to expand a bit more, our engine is designed to record everything that happens within an unmodified Linux process. So we can actually take a program that's been compiled in any language, actually, with any old options, record it running on Linux, and then we can load up that recording later and review everything the program did. We can record it down to machine instruction precision. So you can step to any machine instruction that ever ran and inspect any data from memory you want. And we can do this in many languages. So we support the general families of compiled languages, C, C++, Rust, Golang, Java as well as a kind of alternate kind of runtime. We're always looking into more. So Kotlin and Scala work along with Java because they're all JVM languages. We're interested in Python, JavaScript, TypeScript in the future as more interpreted languages. So I'd like to give you a sense of what this looks like to start with. So I'm going to switch over to my terminal. We won't spend a long time in here, but I'm just going to run a program and it's going to crash. So apologies for the terminal use, but that's how I live natively. We also have VS Code and C-Line JetBrains support if you prefer a user interface that looks a bit more graphical. But what I'm going to do here is bring up my dashboard layout. So it's like a text version of an IDE. And I'm going to show you this program, which has just crashed within our time travel debugging system. What you can see here is, well, we seem to be somewhere inside the implementation of pthread kill, which is how Unix processors send signal to each other. And you can see here, we're here because we decided to abort because something failed in this program. So the first thing I'm going to do is use the reverse finish command. and I'm going to start popping frames off the stack. So I'm actually uncalling functions here, rolling back to before they ran. And I can wind myself backwards through the history of this program. And you can see the local variable values changing as I go backwards. And you can see me stepping backwards to find out where the problem actually was root caused. And we can see here, this program crashed because there was corrupt data in a cache, which is good because now we know the immediate cause, but it's bad because we don't actually know why the cache got corrupted. This is as far as you could get with, say, a core dump in a conventional debugger. Actually, I want to show that we can go a bit further with this. So I've got another terminal here where I've loaded an AI assistant. We're going to ask that for help. So this is the same program that I've just shown you, but what I'm going to say is I'm going to invoke this explain command, which I'll talk more about shortly. I'm going to say explain what went wrong in this program. So I'm not giving it much context. I'm relying it to infer the context from what it sees. And while we're here, I'm going to say describe in the style of a traitorous grand vizier who is also plotting to overthrow me. And that will get us slightly more interesting debug output. So I'm going to run this. And while it works, I'm going to explain what's happening in the background. So what's going on here is that we've fired up inside our debugger, we fired up a kind of captive instance of a coding agent, Claude Code in this instance. And that's running behind the scenes to connect us to the LLM and give us smarts. What we've then done is we've exported the control of the running debug session from my source level debugger back to Claude Code so that it can take control. And now it's able to explore this and try to figure out exactly what went on behind the scenes. So it's running along here and it's working backwards in time through this program, just like you saw me do interactively, to reason about what's actually gone wrong. Now, some interesting stuff to talk about here. So first of all, to make this work well, we discovered that you can't just feed it an LLM a kind of unmodified set of debugger controls and expect it to do something reasonable. We found there's too many different sharp edges for it to get confused by. There's too many tools and too much variety. So actually what we had to do in designing this MCP integration was to provide a really targeted set of tools. It almost started to look like UX design for an LLM. And we ended up building this set of tools that can only run backwards through a recorded session. In other words, always working from effect back to cause. And actually, the number of operations we need to support is maybe about 8 to 10 out of potentially, to be honest, hundreds that the core debugger is able to expose. And I think a key lesson here is that you have to work with the grain of the LLM when you're building MCP tools to make them work well. I'm sure people in your audience are familiar with it. It was new to us as systems programmers, and it's kind of a distressing experience the first time we realized that we just had to do what this brain in a jar was telling us we needed to do. What's happened here while I've been talking is it's walked backwards in time until it found the cache corruption. And now it's walked further back in time using this last value command to query back in history, where did this corrupt cache value actually come from? Because that's our root cause. It's actually not the immediate place we got bad data from. It's the place where that bad data was first computed. And it's now worked its way back in history to understand how that actually got computed. And there's various things going on here in this program. There's a fundamental, there's some kind of type truncation error. There's some maths errors. There's the cache corruption that's then picked up later because we didn't validate it at the time. And here we see the Grand Vizier has determined the true treachery. So, in its infinite wisdom, truckles darkly, blah, 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 foolishly tries to calculate square root of -1. That's bug number 1. You can then see it's explained the bug's location, which I should fix before it seizes power from me. And just as the guards have failed to check the boundaries of my palace, the code has failed to check the boundaries of mathematical operations and a loop, as it happens. So, this is one example. This is a small bug. Actually, we scale this up to larger programs all the time, and I'm going to show you one of those next. Just wanted to just as an analogy, my coding agent, the first time I used it, tried adding printfs to my program and then reading the output to see what the bug was. And it struck me that this was like watching a futuristic Terminator try and hunt a woolly mammoth. So I tried to ask it to, I tried to ask Gemini to generate a picture of it. I thought the mammoth here didn't look threatening enough, and I asked it to be a little bit more scary. And I got this, which I think we can all agree is a very scary mammoth. Now, what I want to dig into in the rest of this talk is the idea of, well, can we do a more sophisticated program than the basic example I just showed you? So here we have an example of a session of Doom. This is a game of Doom I played, I guess, a few weeks ago now. I'm not very good at it. You'll see as I play through the recording. So you can see the frame buffer of the Doom process displayed in the top right-hand corner as I replay the whole recorded session. And as we're doing this, what's happening is everything the game did is being recomputed by our time travel engine. This bit I got stuck in the menu system because I panicked and pressed the wrong key. And finally, we replay up to the end of my session. Now, what I'm going to do with the AI here is ask it a kind of a human level question. So I'm going to say, when was the second zombie killed in this playthrough? So we're not asking now about a crash. We're not asking about specific values of variables or saying set a breakpoint here and run backwards. We're asking it to help us understand something that is meaningful to the human. And we're relying on the LLM to kind of translate from that level to the mechanics of the application underneath. What it's allowed to do at this point is view any of the source code it wants. So Doom is a non-trivial program. It's not as large as what we usually work on, but it's definitely quite a few files, quite a few thousand lines of code. And it's allowed to go look at any of that code it wants using its usual agentic retrieval, analyze what the code is doing, read the comments, read our question, and figure out a strategy for answering the query I made. And what you can see happening on the top right is as it moves back and forwards within the machine instruction precise recording we've given it, we're going to see that frame update and we're going to see its reasoning appear on the screen. So you can see here is now working backwards. It's found this variable, players element 0.kill count, which I didn't have to tell it about. And it's now using that to iterate backwards in time, saying, okay, when was the kill count last incremented, one at a time, until it finds the point where the second zombie was killed, as I asked for. You can see we're back at the point where I got stuck in the menu now. There's a few interesting things going on here. One is that the AI actually has to interpret from my description what in the game of Doom is a zombie. And you'll sometimes, I don't know if it said it this time, but you'll sometimes notice it mentioning that actually the last enemy I shot was an imp and that isn't a zombie. Let's come back now to what looks to me like the second zombie kill. You can see there is one zombie on the floor and there is one with the gun pointed at it. So this is going to be the exact moment that I pulled the trigger on that kill. And what Claude does now in the background is gather some supporting information for me. So it's quite helpful, actually. It doesn't just answer my literal question. It goes and finds supporting details. It goes and finds typically information about where in the level this happened, what wall clock time this would be in terms of game ticks. And then it retrieves kind of a complete summary that it's synthesized in its brain and summarizes for me. So at this point, you can see we've got bookmarks. It mentions bookmarks. I'll have a look. We have a timeline within the recording history, and I can go and inspect these bookmarks to see what happened at different points in time. And I've got its description of exactly what happened. So at this point, I think the key things to note are it's been able to use our recording technology to rewind all the details of what happened in this playthrough. And it's been able to use those to help it kind of help guide it through this large, complicated real-world source code base. But it's also been a partner to me. It's been able to translate my thoughts into what's needed to answer my question. It's been able to create bookmarks I can use to jump around in the recording history and investigate myself. And actually, all of this is providing an antidote to hallucination, because we are providing it with a ground truth of what happened in the system. We're giving it the ability and requiring it through prompting to check what it says has happened against the real recorded history, and to give me reference points I can use to validate what it's told me. So I can go to these points in time with a Hugo bookmark, second zombie kill. We're already there, so it won't make a difference here, but I can jump about and I can check its reasoning, and that enables me to validate what it said rather than having to take its word for it. What we're working on now is scaling this to work with real enterprise code bases, tens to hundreds of millions of lines. We're increasingly using this to tackle complex bugs in real open source and closed source software. And it's going pretty well. So I would recommend, please do come try it out. Talk to us. You can find me on LinkedIn. You can find us generally on socials, or come to one of the many conferences we go to. And it's going to be an exciting ride.
Awesome, Mark. Thanks for the demo and the talk. It was really interesting. So, I didn't really quite catch the moment where you guys actually built an MCP and how that MCP was being used. So it sounded, I heard you say you had one and you kind of went through the learning process for it. But is that MCP something that you need to use? Is it being used inside your product, or is that an MCP you see kind of a person being able to add to a different IDE to call sort of undo data? So
there's a couple of different ways of interacting. So all of this is exposed over the MCP server. If I scroll back up within history, you'll see that we've spawned a Claude Code instance in the background, so a terminal-based coding agent, but we're using it headless here. And we've actually exported this, what was an interactive debugging session, for remote control over MCP. Every time you see one of these boxes that says debugger call, that's an MCP call coming back to us from the captive Claude instance. So you can do this two ways. I've simplified it a bit because we're short on time, but the explain command is a way of invoking a captive CLI coding agent and exporting the session to it and getting it to kind of drive. The other thing you can do is you can run our MCP serve command, and that simply serves up the same functionality for an external agent to connect to. So we find there's kind of one of two ways. Either you have a command line coding agent and you're a debugger person and you want to add intelligence to your debugger, or the flip side, you're a coding agent person, you want to connect your coding agent into our recording. Either way works. It kind of depends what world you want to live in. We support both.
Awesome. And architecturally, we're here, the product that you guys provide, it's open source, closed source, SaaS. It's
sure. So our time travel debugger itself, that's a closed source component. We do have some open source code within it, and we supply back our changes to that. What we also have is the implementation code for the explain MCP server is actually open source. That's available on our GitHub undo.io repositories. And actually that is open for further study, integration with other debugger systems, etc.
Hey Mark, I have a question about this, your amazing technology. I'm curious your time travel technology. How much resource does it consume? Like basically in two aspects. One is like a session like this Doom session like that. What's the how much data did it actually generate? The other is can I run production workload on this? Like how much slower then does the program run under your time travel system?
Sure. So the performance typically is 2 to 5 times slowdown on CPU bound execution. There's some additional overhead if you're heavily using multiple threads. And the memory overhead is about, you should allow about 2x what your program usually requires.
What about disk? What about output data? How much data?
Output data. So I can show you this recording was 358 megabytes for that playthrough of Doom.
Not bad.
We generally, and that will have sucked in all of the supporting libraries it contains, all of the debug symbols available, so that this recording file can actually be portable and be debugged on another system sensibly. We generally say budget a few megabytes per second of execution is a good rule of thumb. Is workload dependent, so that's something we usually have to characterize.
Great, thank you.
Yeah, and I was just going to say, in terms of production use, yes, you can use it in production. People do. It depends on your workload again. Some people need more responsiveness in production than we currently provide, but we're always open to a conversation on that, and we've got some pretty cunning plans for how we're going to get that overhead down in future.
Mark, how do people try this, buy this? Like, how do you even sell something like this? What's the process for, purchasing it or using it? You said it's not open source, so I need to get the trial, I'm assuming, or try it in some way or another. And then how does that work?
What I'd say is go to undo.io and click the button that says free trial, and you'll get something cool to play with. In terms of sales, we mostly work on an enterprise sales basis, which means I'm afraid you have to talk to a human. But the point of the free trial is you can kick the tires first and see if it's worth it for you. We've got excellent support. That's support at undo.io. If you have any issues during your trial, we'll come and hold your hand. We'll come and make sure it works right for you. We prefer to sell to larger organizations because as a small company, we need to make the deals count. We also have free licensing for open source developers and for academic users. So all you need to do is tell us the details of your open source project or give us an academic email address and we'll get you set up with that.
Awesome. All right. Well, Mark, thanks so much for coming on today. Shen, did you have any other questions? Awesome. Well, Mark, it was great. Thanks for staying up late. I know you're out in Cambridge, and so it's well, I guess not that late over there, but thanks so much for coming on. It was a great talk, and yeah, I think Mark just left. So with that, thanks everybody for attending today's talk. We'll be back next week with a lot of great content as well. Have a great day. Oh, I just ended the.
Sorry, I cut us off, but I think we worked out okay there.